What happened to Mars's atmosphere? Put simply, it was lost to space. The longer answer is that Mars, over many years, transformed from a planet that was able to support liquid water at its surface into the cold, dry, thin atmosphere of a planet that we see today. Early Mars had rivers, lakes, deltas, and minerals that form in the presence of water. Those features tell us that liquid water once moved across the surface. To keep liquid water stable, ancient Mars likely needed a thicker atmosphere and a different climate. But Mars had two major disadvantages. First, Mars is small, so it has a smaller gravitational pull than a planet like Earth, and that makes it easier for the particles that make up its atmosphere to be lost to space, especially in the upper atmosphere. Second, Mars lost its global magnetic field early in its history. Today, Mars has crustal magnetic fields in some regions, mostly in the southern hemisphere, but it doesn't have a strong planet-wide dipole field like Earth's. And that's important because a global magnetic field is intimately connected with how the solar wind interacts with different planets. Without the protection of that global magnetic field, the upper atmosphere of Mars became a lot more exposed to the ultraviolet radiation from the sun, as well as the solar wind's plasma. Ultraviolet light can break apart and ionize atmospheric particles, and the solar wind can interact with those particles and remove them from the atmosphere entirely. Energetic particles can also transfer momentum into the upper atmosphere, and they can drive escape as well. But this didn't happen all at once. Atmospheric escape happened over billions of years. The young sun was also more active than it is today, so early escape rates were likely much higher. Some carbon dioxide may have been stored in surface minerals or even hidden away in polar reservoirs. But spacecraft observations have shown us that this atmospheric process and interaction with the solar wind has played a large role in the atmospheric escape. So Mars didn't simply freeze up or dry out in isolation. It lost the protection of its global magnetic field, which left it exposed to the sun, which led to the atmospheric particles escaping off into space, and this led to the climate of the planet itself changing.